Hey Geometers, welcome back to another video lesson. I'm Mr. Forster, and we'll be covering Unit 2, Lesson 2 on reflections today. The homework for my students is in Delta Math, and it is the Delta Math Reflections assignment. So without further ado, let's go ahead and dive right in. With reflections, to give a name or definition to these, one of the things that we can describe them as is a flip across a specified line. So we are going to taking our image, our figure, and we're going to flip it across whatever line we are told, or conversely, if we are told what transformation takes place, we can figure out what the line was that image was flipped across. So let's look at an example of each. So we're going to start off with the point L here. Let's use some blue for L. So L is going to be at this point, -2, 5. So I'm going to go over 1, 2, and go up 1, 2, 3, 4, 5. So it's going to be right up there. So I'm going to be at this point for L. And then it says we're going to be reflecting in the y-axis. Another way to read this is, rather than saying in, we can say across the y-axis. So for that word in, we could replace that with across. So the y-axis is going to be our vertically run axis right here. So I'll highlight that, color that in orange here. And so I'm going to zoom in and make it a little bit easier to see. But what I would be doing to reflect across this axis is, if I'm at L here, I'm going to see, well, how far away from this vertical line am I? And it looks like I'm 1, 2 units away. And I want my new point to be the same distance on the other side of that line. So if I go from that line and go 1, 2 more points, I'm going to end up right there. Let's color that in. Oh, let's use some pink. I'm going to go right here. And this is now going to be a new point, which we call L prime. That little tick mark up top, we call that the prime symbol. So I've taken my point L and I've flipped it across my line. I've gone 2, 2 away on the left and 2 away on the right. So I would be creating a perfect mirror image on either side of my line that was given to me. So I have successfully reflected L across the y-axis. All right, let's look at another example where we go in the other direction. We're given what the transformation that occurs is, and we are told or asked to find what line it was that was actually reflected across. So we'll zoom in off the start here, and let's get some points up on the graph. So we have y is at 3, 3. We're going to go over 1, 2, 3, up 1, 2, 3. So my point's going to be right there. Let's fill that in. There's y. And we'll do some purple for y prime. So at -5, 3. So we're going to go left 1, 2, 3, 4, 5, up 1, 2, 3. So I'm going to be right there. There. All right, so there's y prime. And again, I'm trying to figure out what line was it that it was reflected across. So these are both at the same height for our y values. No pun intended there. But we do know that our x value has changed. So if we look at our previous example, same thing happened here. These are both at the same height, but their x value changed. And to do that, we needed this vertical line. So we were flipping over a vertical line. So we're going to use another vertical line here. And if I count how far apart these are, 1, 2, 3, 4, 5, 6, 7, 8. Well, I want that vertical line to be right in the middle. So halfway from each of these is going to be, half of 8 is 4. So if I start from the left and go 1, 2, 3, 4 to the right, if I start from the right and go 1, 2, 3, 4 to the left, I should end up in the same spot, which is right here. And so this vertical line that passes through that point is going to be the line that I want. So let's fill that in with, we'll use orange again for our line of reflection here. All right, there's my line. And if you notice something about this line, well, each of these points that's on it, this point would be at -1, 0. This would be at -1, 1, -1, 2, -1, 3. And anywhere I go on this, the x value is always the same. The x value is always -1. And this x equals -1 describes our vertical line here because all of the points on it have the same x value. All right, let's look at, instead of just a point, if we were to reflect an entire image of a figure across some line, we're going to look at triangle ABC, and it's going to be reflecting across the line y equals 1. So in our previous example, we mentioned that a vertical line is described by x equals some number. So this y equals 1, this is going to give us a horizontal line. And so the horizontal line is going to be everywhere that y is 1. So if we go up to 1 for our height here, everywhere along this horizontal line is going to have a height of 1. So I'm going to go ahead and fill that in. All right, next, let's fill in some of our points. So we'll do A in blue. B is at -1, -1. So if we go left 1, down 1, that's going to be A. And then we'll do B in purple, -3, 2. So I'm going to go left 1, 2, 3, up 1, 2. So B should be right there. B. And then we'll do C in green, -4, -6. So if we go left 1, 2, 3, 4, down 1, 2, 3, 4, 5, 6. C should be down right there. All right. And then we can connect our shape. I'll use black pencil color here to connect our shape. All right, so there's my triangle. Poorly drawn, but that's all right. We are going to now reflect it across our line. So I'm going to kind of repeat the process we looked at in our previous example, or the first example that we looked at. And that is I'm going to look at, well, how far is A from my line? And so I'm going to go up 1, 2, and then I bump into this line here. And that means I'm going to be 2 above from my reflected point. So I'm going to go from my line 1, 2. Here is A prime. For B, B is 1 above this horizontal line. So the reflection, or B prime, should be 1 below. So 1 below, and here will be B prime. And then for C, we are 1, 2, 3, 4, 5, 6, 7 below. So I need to go 1, 2, 3, 4, 5, 6, 7. So we're off of our original graph, but that's all right. I've got this extra little line separating my pages up above, so I'm going to use that. So I'm going to say it's about there for C prime. And so I'm going to connect these. Let's use a little bit different color to connect them. We'll use kind of this charcoaly color here. So my new figure, that is the reflected version of my old figure, will be that charcoal figure above. I'll rewrite B off to the side here so we can see that a little better. Okay, so I have successfully reflected across my horizontal line. And again, when my line is horizontal, I'm looking at the vertical distance to that line and making sure it's the same on either side. So I have a distance of 1 for B, 2 for C, and then it was, 2 for A, and then 7 for C. All right, moving on to our final example for today's video lesson. Again, we'll highlight the thing that we're reflecting across in orange just to be consistent. So we're going across the line y equals x. So the line y equals x, a little bit of a review from algebra. We have our y equals mx plus b form. Well, in this case, m is 1. So we have y equals 1x, so the slope is 1, and b is 0. So our y-intercept is at the origin. So when we can draw this line, which we'll do in orange here again, as I have the y-intercept at the origin at 0, 0, 0, and then I have a slope of 1, so go up 1 over 1, up 1 over 1. I'm going to do my best to connect these like that. There is my line y equals x. All right, let's look at our vertices of our triangle ABC. So we'll use some of our similar colors again. We'll use A in blue. We did B in purple last time. And C we'll do in green. All right, A is at the point 1, 3. So I'm going to go over 1, up 1, 2, 3. So there's A. B is at 1, 5. Let's move. There we go. All right, B is at 1, 5. So we're going to go over 1, up 1, 2, 3, 4, 5. So there's B. And C, which we'll do in green, is going to be at 3, 6. So 1, 2, 3, up 1, 2, 3, 4, 5, 6. Here is point C. And again, I'll connect these. Our triangle. All right, there is my triangle ABC. Much cleaner drawing this time. So here's where maybe the trickier part comes in is, well, how do I reflect it over this line y equals x? And we'll play with this and we'll do some exploration with this in class together. But one of the ways that I can do this, and to introduce you to one of our algebraic rules for this, and we'll do this in red, is if I take x and y, my two x and y coordinates, what we're going to do is we're going to swap their positions. So the x value becomes the y value, and the y value becomes the x value. And later in Algebra 2, you'll learn about how this ties into something called inverse relationships, or an inverse function, and how all inverse functions have this symmetry over this line y equals x. So a little bit of a preview for some of your algebra concepts later on, but we're going to take this, and kind of similar to how we try to see how far away these are, we can kind of do that with A at least, how it's kind of one diagonal across. So it should be one diagonal across this way. And so if we look at the points for A, A's points are 1, 3. So if I then go to 1, 2, 3, 1, we see that it kind of lands on that same spot here, or it does exactly land on that spot. So we have A prime here. And again, I can kind of double check myself, one diagonal away, also one diagonal away, but it also works that 1, 3 goes to 3, 1. Let's do the same thing for B. So B is at 1, 5. So it should go to 5, 1. So if we go over to 1, 2, 3, 4, 5, and then up to 1, here is our spot for B prime. And when it's conveniently on these nice clean points, we can kind of double check. We're 1, 2 diagonals away, 1, 2 diagonals away. That one also works. Our rule checks out. And then finally for C, we start at 3, 6. It's going to go to 6, 3. Again, we're just following the steps of take my x and y and swap their positions. 3, 6 becomes 6, 3. So I'm going to go over 1, 2, 3, 4, 5, 6, up 1, 2, 3. And here is where C prime should be. Sides of my triangle here. My new triangle. And let's just double check to see that works for C. So I'm 1.5 diagonals, half and then 1 diagonals away. So 1.5 diagonals on either side of this y equals x line. But again, algebraically, I think is maybe the most straightforward way to do this. I can apply this rule as well. But graphically, we see that it kind of follows the same concept as we had in our previous examples. All right, that is all I have for you as far as the examples for our reflections go. Your assignment again is in Delta Math. So don't forget to make sure you have that Delta Math account set up and that you are all good to go on all things Delta Math. If you have any questions, feel free to reach out to me via email. Otherwise, I will see you in class and have a great day.